And the event 5, 4, 3, 2, 1.
Okay.
Now. Good morning. Hello.
Hello,
Nice
everybody. Hi.
nice to have you here. It's our next webinar of because of Hour of Code, and we have Mohammed Arif with us, who will present a house security alarm system today. So I leave you in hands of Hama, and hope we will have a great time.
Okay. Thank you so much. I appreciate it for presenting me. And hi, everybody. I would like to present myself. My name is Mohammed. My nickname is Ham also. I come from Iraq. I came to Poland to do my master degree in Politechnika Gdansk and robotics and automatic control systems. Now I've been working in Amazon for 3 months, and today we are going to do and show some cool relationships between coding, softwares, and hardware. And maybe some of you have heard about some controller board, which is called Arduino. So we are going to make a small demonstration of how a house alarm system would work and operate. As you see from the picture, the first one, you can see we have now smart house applications. We have smart security systems which can give you feedback to the owner of the house if you have a breach into the house, if you have any kind of problems. So we will just make an overview on this and how this works and how these sensors and how these hardwares are working and how the software behind it is operating. So during the presentation, you can feel free to drop any messages through the message chat box, and I will try my best to answer your questions. So off we go. First, we will go with our roadmap through this presentation. Since we have like 1 hour, we won't do much of detail. I just want to give you the overview of how this thing is working. So we will talk about what is a program or a software. Most of you knows what is it, and what is the hardware, and what does it mean. What is a sensor? What is the meaning of data? Can we combine all this together? And we will do some cool application and a little demonstration. So what is coding or programming? As maybe some of you heard, maybe some of you never, and maybe some of you curious to know what is it. It is the edge cutting technology of nowadays. It is simply, in simple words, is about how to tell your computer or the machine what to do by giving it step-by-step instructions to follow. So it's about how to learn the language of a machine. So we will know what is the language of a machine. What can be a hardware? The hardware can be any electronics or gadgets you can see around you. It can be a monitor, it can be a keyboard, it can be the fan you see here, it can be the motherboard of your PC, or whatever, a piece of electronics, which is composed of silicon and all the chemical composites, which gives it its physical properties with conductivity, electricity, and all the things behind it and the physics that you study. So all the story starts from here. You have all these little guys, these little components. They all come together, and they made this very technology that we have nowadays in our lives. And these are simple components, each do simple roles, but when they put them together, engineers and the efforts and the technologies and the science behind it, it can give you and limitless capabilities and a lot of advantages. And they come up to make things like this you see in the motherboards of your computers and your PlayStation or Xbox or any electronic device. You would see something like this, and this is a motherboard, and this is the main hardware piece. So what can be a computer language? Before jumping into software, A computer language is simply something called a binary language, which is composed of only two things. It's 0 and 1. It's just like saying yes and no. It's just like having uh, something which is 0, which means no for a computer, and which means maybe off, and 1 means yes, or it's on, or it's applicable, it's okay. So a computer doesn't have in between like this. For example, if I ask you in the morning, like, how are you? You just say good or bad. You don't say, good, maybe some little better. You don't have such thing with computers as a primitive language. Then what composes a software and how you want to talk with a computer, it all starts like this. From the graph we can see, we start all from high-level programming. Something is called high-level programming language, which is like languages like C, C++, Pascal, Java, Python, or whatever maybe you heard in your life. Then you have something called the compiler. This is the backscene of what is happening in your machine. And this compiler here is like the magic box which converts these instructions, which is in high-level programming language, which we write in our computer, that converts us to these 0 and 1s that you see. That these 0 and 1s, we can never understand it if we read it like humans, because this is only the machine can process this. So this compiler does this, and it turns it into something called low-level programming language, which is called machine or assembly language. And this was the first language ever created in software engineering, because it's conducting and it is having a direct contact with the electronic pieces of any hardware. Then if we go to what are sensors, sensors are all the same. These hardware components also, they come together to make things called sensor. For example, you have a color sensor, which can identify the spectrum range. Maybe you studied in physics if you are in high school, maybe you studied before or learning currently. You have the light spectrum, you have the ultraviolet light till the red and the redshift, and so many. And from from this color sensor, it can detect the spectrometer of these colors. For example, an alcohol sensor can sense the chemical composition and the airborne particles and can detect the alcohol. The same for a gas sensor, and the same for all other sensors. For example, an ultrasonic sensor, this sensor is operating just like how a bat can find its way by sending sound waves from one knob, and it receives the delay which is coming back from the reflections of the sound, and it can tell you the distance by only using ultrasonic sound waves, and so many. Then let's talk about data and what can data be. And data, we have something called raw data. It's all composed of 0 and 1s, and it's the language of the computer that you get. But data doesn't mean information. This is what most people confuse. Nowadays we live in a world that's full of data because we have a lot of technological advancements, we have a lot of developed hardware, we have a lot of sensors, we have a lot of capabilities to measure a lot of stuff, but these are all data. But to make them into a useful and in a form that we humans can understand, if we want to develop something, if we want to improve something, we have to put it into something called information. And how you form information, you have data, you combine it with all the physics, the math, the biology, the chemistry you study, all the studies and the science and the STEM you do in your high school and in your education, and you interpret these data because these called scientific tools, these are methodologies and mathematics and calculus, derivations, integrations. All these gives you tools to interpret these data, and this is what most branches nowadays do. They are called data scientists or data analyst. So they convert it into information. So when we have information, we humans can comprehends this information and we can understand it. Then we form experience with this. We learn. And with learning, we make decisions. And to alter and our behaviors and to decide what to do upon the data we had and upon the tools that we had already, which is education, let's say, and which is all the math and physics and etc. And somebody saying, isn't that complicated? Okay. Which part I can go back to, and I can if I can go back to and make it more clear or simpler. Okay, and then we make decisions based on this information that we get. Then, not going into much details, we can put everything together and let's see if we now just keep in mind, you know what is a sensor. It can measure data for you, and you have a hardware and you have a software, which you know now how to talk with a machine, which is called coding. Then let's talk about the type of sensors, and these sensors which we are going to use in our demonstration. So not to overwhelm you, this sensor is a motion detection sensor. This is basically the same sensor when you enter your apartment and the light turns on, and when you just leave, the light turns off. This is the same sensor that is sensing your motion while you are moving, and it detects the motion of everybody and every moving object. And this is a vibration sensor. This vibration sensor and these sensors, we will see them in a real live demonstration. So you don't need to freak out or something. I know it might sound overwhelming. My point is to give you a view about how these things work in our daily lives and how these things are cooperating and how important it is. Maybe in the future you want to you want to pursue a field which is related to electronics, which is related to engineering or something, because you can do limitless and unbounded applications with these things. And the sky is the limit, as you know. Going back to the vibration sensor, this sensor is one of the sensors, for example, which detects rapid changes in movement. For example, if you attach this sensor to a glass, and if somebody breaks the glass, it will know that there is a sudden change, impact happened. So vibration happened. So you can use the sensor as a glass breaking sensor. For example, if a thief breaks into your shop, into your house, or into your property by breaking the glass or the door or anything causing an impact, this sensor can detect for you. And we will use a magnetic door sensor. This is a two-piece of magnets, which is an electric magnet. It's a very simple sensor. Once the two magnets are together, they are attached, this sensor can tell you that the door is closed or the window is closed. Once it's open, it will lose the magnetic field and it will tell you that the door is open or the window is open. And we will need only a computer to connect this motherboard, which is the Arduino. The Arduino is a very open source and easy to program microcontroller. In your age, when I was in your age even, I was playing around with this microcontroller. You can see a lot of tutorials, a lot of videos, a lot of things on YouTube, on a lot of courses online to learn, because it's simply not only educational, it's for hobbyists also. A lot of people who do hobbies, they deal with these things, and you can do a lot of cool things. You can do things from building your own helicopter, your own drone, till you do a lot of scientific research with this tool, because you can control it and you can read to it data, put into it data, and tell it what to do for you, and it will do for you, as we will see. And Going further, and the softwares that we will be using now to show the coding and the thing, it's simply one. It's the Arduino itself, because the Arduino has its own application, which you connect it to the computer and you connect it with a USB cable, and inside it you can do your coding here. And Fritzing is also another software to show you the electronic connection and the wiring of the sensors. It's also a simulation program, but you don't need to bother about it. I'm using it only for the purpose that maybe one day you want to dive deep into this and to learn about it and make your own circuits on a computer, that you don't need to buy the wires and things and make it and see how it looks like, as we will see. And our circuit will be something that will look like this, and we will see it in a better way. So here, if I may share my screen with you. So further, do you have any questions? If before, because this part is the theory, like how the things is working, just to give you a general idea and general overview. After this, we will go into the code line by line and see how this works, and I will show you the circuit of it. So before that, if you have any questions or any things in regard of what is going on, I'm very glad to explain again. Okay, the practice. Okay, cool. Just a second. The project that I'm going to show you is a part of, it will look like something like this. This is a very complex project. It's a part of a bigger project of my colleague who's working on a high-level security systems, which is connected to your phone and a smart house. And we will demonstrate a simpler version of this, which will be looking like I will show you the simpler form of it. Yeah, this is what we will be doing now. So I just want you to see, and this is the fritzing that I told you about, and you can zoom into and you can see the pin number, every specification. You can find every sensor here. You can drag and drop and put here, and exactly. And here, this is our board. This is something called breadboard. Maybe some of you familiar with. You can connect the positive and negative, the ground and the plus voltage. Here, you can connect. This is our vibration sensor that we talked about. This is our motion detection sensor. This is our magnetic lock sensor. This one is an LED that we added just as an indicator when something happens. And this is a buzzer. A buzzer is just like a speaker, let's say. It makes sound, as we will see. And this is a resistor for the LED, because this LED works on low resistance. So in order to avoid burning the LED, we had to put this. You don't need to worry all about this. We will go into the coding. And just a second. Yeah, we will go into the coding. And this is the Arduino now that we talked about. Here we will go line by line. What does these things mean? It might seem so long for you if this is your first time you see what the code looks like, but believe me, it's just a set of instructions. Once we read through, it will be all clear. So, okay. So here in the first of every part of a code, we define something called the variables. A variable is just, you can think of it as a place to represent our sensors and hold our data, because this is a software. Just imagine it as a blank paper. You want to build everything in it. You are the architect, you are the engineer of it. So how you do, you int means integer. That means I want to represent a number here, constant integer, and I give a name of my sensor. Okay, this means motion sensor. I gave it a name, and equal to 2 is the pin number on the Arduino. So if we go back, to the fritzing, because just one time I want to go back to the schematic, so you can see what does the pin 2 mean when these numbers mean. These numbers are represented here on the Arduino. These are called pins, and the same pin here, you see the same pin 2 here, you see that you follow the yellow line. It's connected to one of the cables which is connected to this sensor, which is our motion sensor. And the same way, this is, for example, it's red, it's positive voltage, and this is the negative, the ground. And the same for all sensors. You see all of them are connected to specific pins. Not going into details, but I wanted to show that these numbers that you are assigning them that equal to this number, they are coming from here. So going back, to the code. So here the motion sensor is connected to pin number 2 on the Arduino, and there is something called Boolean. For now, it's maybe complicated to explain this, not to overwhelm you. Boolean is just means it's a kind of value. It can be this 0 or 1. So you just want to tell your sensor work when it is 0, work when it is, or not work when it is 1, or vice versa. It depends on how you want it to work. So we need, for this specific sensor, we need this kind of thing, let's say. Then the vibration sensor is connected to pin number 8. Magnetic sensor is connected to the pin number 3. And the LED is connected to 9. The buzzer, which is this like kind of speaker which makes the sound, is connected to number 12. Then since now we said that this is this sensor, it is connected to this pin, we want to get the data from it. And to get the data from it, you have to have like a box or a container to put this data into. So we will say it's the data int, which means there will be numbers coming into the box, which is called the motion value, which will be the data coming from the motion sensor. We will put it in this container, in this box. And the same for integer. For gap value, I call it gap. You can call it whatever you want. You can call it window value, or distance between two magnets value. You can name it whatever you want, whatever makes sense to you. So we call it the gap value. This is the vibration value, so the data coming from the vibration sensor. And Arduino, let's say, if we talk specifically about this board and this hardware piece that I showed you, there are two main parts when you code it. It's standard, it's never changing. Some first part is called the setup part. So first we have to set up the board before make it work. So setup means what? To tell it what is what. So here we have pin mode. Pin mode means vibration sensor. This means vibration sensor. If we go up, it is what? It's pin number 8. What is pin number 8? Put it to input. That means pin number 8 will be a place to get data. It will get input from the sensor. It will not give out from the board. It should come into the board. Motion sensor the same, because these are sensors, they are collecting data. We want to collect the data, so we will tell them to put input. Motion sensor, we put input. The magnetic sensor, we want to read. But here you can see the LED, because the LED is not a sensor. An LED is just a light. I wanted to tell me what is happening when something is happening. For example, when a window is broken, tell me, blink. That means turn on the LED. So it should be an output. That means make the LED work. Buzzer is the same, is this sound making thing. Then there is one thing in the Arduino, if you want something maybe more complicated, not going into that. It's a name of a protocol to communicate with this board, with this Arduino. So how to see what is happening inside it? If we want to go inside it, we have to put serial communication port. So just know it, it's a communication port. Then after the setup is done, our setup is done now. So what will be happening now, we will go into something called the loop. And the loop is the main part of our code. In the loop, we make everything work. That's why it's called a loop. It works forever. It will keep running as long as there is power to the board and as long as we don't tell it to stop. It will just keep looping and repeating. So in the loop, we will say, what is motion value? Motion value, if we not to confuse, we will go back. It was here, the container that is collect in it the data from the motion sensor, the box, let's say. So motion value equal to digital read, because we said a software can a computer speaks zeros and one, and zeros and one is called binary or called digital language. So we say digital read is to read the data from this sensor, to read the information from this sensor. So how we do it, we say digital read from motion sensor. So read the digital information from this sensor. Tell me if it tells me 0 or 1. The same for all other sensor. For example, for vibration, the same. For gap value, digital, tell me the magnetic, we called it the magnetic sensor from here, above, and etc. Then we will come here, and now we collected data. Then we talked about something called information. Sorry, just have to stop sharing because I have to check the chat box if somebody is asking or something, because I'm not aware. Is everything okay? Because I can see the chat box while I am sharing the screen and seeing the screen. Okay, cool. Thank you. Okay. Let's continue. Yeah. So here we collected the data. Just to summarize again. First of all, we initialized what is what. Motion sensor is connected to 2, vibration is connected to 8, and etc. Then we initialized and defined the containers for this data, the boxes to keep the data that is coming from these sensors. Then we did the setup here, which is telling us this vibration sensor is going to bring in data, which is called input. You put vibration sensor is bringing data. Motion sensor is bringing in data. Magnetic sensor, etc. But for LED, it's giving out data. Like we want to tell us something, not to take inside something to the board, to the Arduino. And for the buzzer, the same. And here we initialize something called the protocol, which is, we will see the importance of this protocol once we hit the button here. You see it's something called serial monitor. To be able to click here and to make it work, we have to initialize this. That's why we put this serial dot begin at, this is a frequency and baud rates and things. I don't want to overwhelm you with this. This is all about some physics and frequencies happening on. It's cool stuff. Then we have the void loop. Now we said here, what is happening on our code will be working inside here. We did the setup, we defined everything. Now we want to make it work. In order to make it work in a logical way, we said we have data. So let's start. So from motion value, we have digital read. We read information from motion sensor. This void loop, why we did this again here? This vibration value equal to digital read vibration sensor. We every iteration, because it's called loop, this will go like this. Just watch my cursor. This code will work like this. It will come to void loop. It entered here. It came line by line. It came to this line. It read the computer is reading motion value equal to digital read. Okay, it read. It goes to this line. It does the same. Line by line execution. It does line by line. And we will see how this line by line is working. So it collected the data here. It did all these operations here that we will explain now. It did all this operation here till the end. Till the end. This is the end. You see, when I click here, you see the void loop. This parenthesis is closing the whole loop. Then once it reaches here, what it does, it jumps back. It jumps back again to the first place. And it repeats, and it repeats, and it repeats infinitely till your board is working, or till you do some coding here and put some logic. Not getting into that, you can maybe later dig deep and dive deep into it and see how it is going on and see how to put breaking cases. It's called switch break, or just make the loop stop where something is happening that you want to code in the way you want. So coming back here, we are doing line by line execution. We came here, we collected, and we read the data from each of these three sensors. Then this is if and else. If and else is just like our daily language. For example, I will tell you, like we are friends, I will tell you, if you buy me a coffee, I will do your homework. Else, I will not do your homework. Just like this. It's just simple logic like this. The same goes on here. For example, here you say if motion sensor, which is the sensor value, if it is high, high means 1. We said the language of a computer is 0 and 1, the binary language. So 0 is no or low, and 1 is high. And Arduino high represents bit 1. That means 1. That means okay. If the motion sensor high means if the motion sensor worked, what to happen? Okay, if this happened, we jump into this loop. We go into another loop. What is happening? We will say digital write means tell the LED high. Digital write means in a simpler language, just make this happen. It's just like a giving order. It's just like sending a digital 0 or 1. You are sending 0 or 1. Digital write LED high. That means turn on the LED. This means like this. Delay is what? Delay is something you can use it, you cannot use it. It's optional. What this delay is doing, it's the repetition of this loop. We said it goes line by line. So it came here, this happened, then it will wait. There is a delay of 500 milliseconds. And each 1 millisecond is 10 to the power of minus 3 second. That means each second is 1000 milliseconds. So in each 500 milliseconds, each time the code comes to here, before jumping to the second one, just delay, wait. It's delay. You can understand what does it mean. You just wait 500 milliseconds, then go here. I want to give it time. I don't want everything to run fast. You can give it 5,000. You can give it whatever you want. So it depends on your program and how you want to code it. Then I also want the buzzer also high, the buzzer, which is the beeper or the speaker, to make sound, to alarm me, the alarm system. Then if it comes here, this logic might be a bit complex, but just have an overview of it. If motion sensor detected something, just turn on the light for me and make the buzzer or the alarm work. Then we talked about something called Boolean. It was here, and this false comes from here. Some sensors, for them, the engineering behind it is like this. 0 is yes for them. Some sensors is 1 is yes for them. So this thing you can know it by reading the information in the sensor and how they built it and why it's like this. I'm not going into much of this detail. Here we do some operations with the sensor, which is related to some logic. If the motion sensor false, for the motion sensor mean yes. You see it's reversed. So not to confuse you, let's just skip this part. So just bear this in mind. If this motion sensor was activated, that means if it detected something, that means it will send 1 to the board, and the board will tell the light to turn on. This whole thing is doing like this. Else is the opposite of it. What we did here was, if this sensor detects something, turn on light for me. But here else, digital write, turn off the light, LED low means off, turn off, 0. Digital write is low, then digital write, the buzzer also low, turn off the also the buzzer, and set, and this is when the motion state, that means the sensor is true. Also, not going to that logic, but if you see here, this part is just the opposite of this part, but they are doing 2 different jobs. It's just this simple. And you can, this serial.println, this is the message that we will get from the box once we will make the sensor work from here. And we will say motion ended. And here we were saying motion detected. That means the sensor, you can put whatever here you want. You can say motion detected dobra, or whatever. You can write whatever and you will see it there. So it's just up to you. This is one sensor, done. Then if we go to the other sensor, we put something similar, the logic. We will say if the vibration value is 0. 0 means it's off. It means there is no vibration, right? So if the vibration value is 0, we will say warning. Maybe there is a, yeah, this sensor also works in reverse. 0 here for it, it's on. And we will try it. If it is in reverse, we will see. If we will make it 1, and we will see how it happens in the demonstration. So, but it's the same logic. Whatever it is 0 or 1, you can send a message to the user. Just wait 5 milliseconds, send another message, warning, Windows is broken. And put another delay and say to the light to turn on and the buzzer to turn on, like this. Else LED low and the buzzer low, or just turn off the LED and don't make any alarm and everything is okay. No vibration happen. This is the opposite of it, negation. And for the magnetic sensor, here is the same. If we have a gap value, this means between the 2 magnetic sensor, if it is closed, that means there is nothing happened. The door or window is closed. If it is open, if this value is 1, that means it's open. And it will send us a message. It will say, warning, door is open. And it will turn on the light and turn on what? The buzzer. Else, if this is not 1, it didn't happen as 1, just keep everything normal. Nothing happened. Window is not broken, and no alarm, and no light on, and no buzzer on. So this is the code here. Just jumping into the chat box, and let me see if there's a question or something. Is everything okay so far, or any question before we go into the application? Okay. Okay, I assume everything is fine, guys. Okay. Okay, let's. Okay, now this was the code. I don't know if Yeah, you see me. This is the code. We minimize the window only because I want now to show you. I will tilt my camera. I have a demonstration. It will look maybe nasty a bit. It's confused, but it is the same fritzing and the same schematic that we saw in the beginning. But this is the biggest part of the project and it's still being worked on. So to be clear, and how this thing looks in real life, this is the vibration sensor. You can hear a voice if I make it near to the mic, and it has an element inside it, which is just like a small ball. Once there's a vibration happening, we will see and read a message, and it will detect a vibration. And here is the, maybe you saw and noticed in the presentation, this is the motion detection sensor here. And it's so sensitive, it has knobs and some parts here and some screwdrivers here that you can adjust the sensitivity, the range, and a lot of physical characteristics and things. It all depends on the application you want to do on the things. The rest, there are a lot of other sensors here that we are not going to go into because they're more complicated. They detect alcohol, fire, thermal heat, and a lot of things. Temperature, leakage, and a lot of other various things. And here, maybe it sounds like a funny demonstration because here we have, let's see, this is the magnetic sensor. So this will be like representing a door. For example, if the door is open and if the door is closed, because the magnets are attached together. And here we have the Arduino that we showed. And all these are the cables and the pins connected to it. This element here is the buzzer that will make us the sound, and there is a small red light here, which this is the LED. So let's give it a go and hopefully everything goes okay, because you know, when it comes to practice, these things sometimes turn nasty. So we will see here. There is a code already implemented in it, and that's why when I will connect it to my PC, this is the USB. This is the USB of it, and this is connected to the board here. So it's just the wire connected to here. I'm going to connect this to my computer, and from the Arduino here you can upload the code. We will see. This is, you see, it's written upload, and here it's written verify, and we will see what are all these buttons means. So yeah. I know you can find much better presentations and representations of these things on YouTube, more professionals and better well prepared. But this is just, let's give it a go. So you see, it's working now because there is a code in it previously. So if we want to upload this code, or even because there is a previous code in it, we said there is a serial monitor. Can everybody see the screen also? Okay, hope you see. Okay, thank you. So this serial monitor, if we click on it, we will see these. We will see. We will see these values that we were writing here. For example, when we were saying serial print ln motion detection, or when we were saying motion ended, or whatever here. So let's click here, and you see this is the messages which are coming from the board and from the sensors connected to it. So from here, because you see we have here the door, I hope you can see. From here we have the door is open. Since the door is open, it will say warning, door is open. So it will keep beeping, and you can hear the beep, and you can see the LED blinking. and this is an alert. You can connect this, for example, to a lot of various things. You can even, for example, this project is a bigger part of, and instead of only giving warning here, it can make a phone call to 911 or make a phone call to police to give a warning that this house is being breached or someone is breaking into the house. So when we close here, let's see. You see, if you see my hand, I closed. It stopped beeping. I open again. Door is open. It senses it. This sensor is sending through these cables data to the Arduino, and in the Arduino there is this code that we did here, and it's being processed and it's being giving feedback from the serial monitor. So if we close here, I put a duct tape. I know it's funny here, just to keep it closed because I need my other hand. And this is the vibration sensor. And in the vibration sensor, look, if we make some vibration, you see, it was racks disturbed. This means like something was disturbed, or like the shelves were disturbed, because we were doing this part of a laboratory project. And it can sense. For example, you see, you hear the voice. This mechanical sensor inside it is sensing that there is some sudden impact. For example, even if you hit it like this, it will sense. You see, if I stop, there will be nothing, no message. But if I keep, maybe sometimes you need to, it will keep racks disturbed. If we put our hands here, you see, motion detected, the motion detection sensor. You see, it will keep beeping 3 times. It depends on the sensor. Then if I don't move, there is nothing. But if, since the lens of the sensor is in the front, if something passes, you see, it will detect it. This is the same like when you enter your apartment, the lights turn on, as I said in the beginning. And you can use, for example, the sensor, you can make this for your own in your home. You make it like a security system. For example, if there is no one in the home, you put this system, and if somebody comes into your house you don't know, then there will be a motion, a detection. And you can know that there is somebody in the house or something is moving inside the house. And you can do a lot of cool other stuff with it, of course. Yeah, and let's, this is the code, how it works, and let's explain these buttons in a fast manner. So we can close here. This button here, what it does, when we click it now, we said in the presentation that we have a high-level language, which is like C, C++, and this, what we did here, is high-level language. What we did here, this is like C++. It's like C or Java. It has its own unique thing. It is all C based, but let's not get into that. It's more complicated software things. But this is called a high-level language. Why? Because we are humans can understand it. For example, the Arduino, the board here, cannot understand what does motion sensor mean. Then you will ask me, how does it know that? Then we talked about the compiler, if you remember, the magical box. This compiler will convert this motion sensor into zeros and ones in a language that the machine can understand. And how that happens, you can learn it by your own, and it's a bit of high level, but you can learn it. It's not a big deal. So how all this is happening, we did all this high level language here. How it is happening here, you simply click by this button, which is the compiler. You see, when I click, you see compiling sketch. The compilation is happening. You see the process is happening here. It's converting the high level language to the low level language, which is 0 and 1, which is the computer's language, which machines can understand. So you see, then done compiling. And here, for example, you can drag it and see all the information and how many bytes and bits and these things. So not to overwhelm you with these things. These are all things related to memory, to RAM, the storage, and all these things. Then after the compilation is done, then we can do what? Upload, which means we will send the information to the board. So if we click here, upload, you see, it will automatically one more time compile the sketch, because this is in case you may sometimes you forget to compile it and you just click upload. The software is just like a double check. So it will already again compile it for you and make it ready, and now it's uploading. So you just wait, the code is coming from here inside the board. So done uploading. So once done uploading, you can wait till the code works, and you can open the serial monitor, for example, once more again, and let's see if it works, because I was playing around with the code before in the presentation, and these things can sometimes have technical issues, but previously there was a code inside it the same, and it was as we saw in the demonstration, it was working. So maybe you see, warning, Windows broken. You see, I hope you saw my hand when I move it. For example, imagine if this sensor is connected to a window, and if this window is hit with a hammer, you see, it can detect an impact. You see, window is broken. The same for the motion. If I want to detect if there is motion or something, maybe there was a typo here, the 0 and 1 that I talked to you about the motion. That's why it's not detecting. We will change it if necessary. And let's go to the door. Door is open. You see, it's telling me door is open and it's beeping. So the same, close it like this. So yeah, pretty much this is it. I hope you enjoyed. I don't know, I hope everything at least was a bit clear, and it could be a bit of insightful. So if you have any questions, any things, any concerns, any comments, I would really like to know. Okay, where you can get all these sensors, you are very welcome, Rafael. You can get all these sensors from Botland. You can get it from Allegro. You can get it from everywhere. It's available everywhere. It's open source. It's free. The software is free. You can download it. Everything I showed you here is free. The only thing you need to buy these things, and they are not very expensive. For example, here you have this vibration sensor. It can cost you maybe 15 zloty or something, maybe less. It depends on the type of the sensor and on the type of the things you want to make. So you can find them on Allegro, Botland. I can let me Botland. This is also a Polish. It's a Polish store, and they have a lot of things. They have even kits like to do these things. So I hope I answered your question. Very welcome. Yeah, guys, these things are really cool stuff. You can do a lot of cool stuff with these things in your future, now, and in the near future, far future. Imagine, like, people do it in the hobby stuff, and I'm doing my master degree on these things nowadays. You can even people do their post PhD things and do use these as tools for their experiments and things. Yeah, exactly. Yeah, they are cool stuff, how these things works. And if you dive more deep into how these sensors and these things works, the simple mathematical equations and the physics that you study in your high school that sometimes just make no sense for you because you just see the theory behind it, you all see the application and cool stuff in it here. These sensors are used in your cars and your mobile phones and every technological piece you have around you nowadays. So it has all the science, all the math, all the physics in it. You can really enjoy playing with these things. You can invest your time. Nowadays, you have maybe a lot of time to invest, so you can buy a piece of this with your friends from time to time. You can gather, do a project. There are a lot of projects, a lot of open source projects on the internet, hundreds of thousands. You can find a lot of stuff free, and all the codes are there. You can just copy paste and understand and make your own, not just only copy paste, because it's cool to understand how these things work. Yeah, so I really encourage you to do these things if you are in your high school level now, and if you go for these things from this stage, believe me, you will achieve a lot, and it will be a big investment. Yeah, copy paste and modify. This is what the world about today nowadays, because most of these things are done. Just it's good, just make it better, or it's bad, just make it better. Because you don't have to start from scratch to build this board, for example. Some people do it, and they enjoy it, but it's a lot of time and investment. So yeah. If there will be any other questions, I would be really glad. You can reach me if you want. I can share with you my email if you have any questions, if you have any further concerns, how to find these things, how to do these things. I will be very glad to, if you want, of course. Very welcome. I am very glad that at least I could show you something that's interesting for you, or it can make you interested, at least nowadays. And maybe it will be something that can change your way that you want to pursue your future in your education and in your career and your life, because it was for me like this. People like this, teachers, I had mentors like this who showed me these things, and I was really getting interested since my high school and secondary school, and that's why I decided to study robotics and these things, and they are very cool. Yeah, it's all the science and physics and technology all together, and you can do a lot of cool things. Nothing can stop you.
Okay, so thank you, Mohammed, for this inspiring presentation, and I hope that it was really interesting as our participants wrote. So see you next time.
Thank you so much. I really appreciate it. I'm very happy to be able to reach you at least with even 1 hour of code. And I really appreciate your efforts for organizing this event. And I appreciate the attendees and their attention and their patience. It sounded a bit complicated and crazy maybe in the beginning, but it's all good. You are all smart people and you can handle these things. This is the new era, and you are the leaders nowadays. So by learning how to make coding and how to learn how these things work, you can do whatever you want, and you can decide what is right and wrong and how this world is changing, and all the things happening around is all connected nowadays together. We live in a world which everything is connected, everything depends on other things, all fields are interconnected, so it's very important to know what is going on.
Okay.
So,
Thank you once again. See you.
Thank you so much. Have a nice evening and a great weekend, everyone.